Explorer 1, NASA's farthest-traveling spacecraft, continues its remarkable journey through space, transmitting invaluable data from the most distant regions of the universe. For nearly 5 decades, this incredible spacecraft has revolutionized our understanding of space. However, recently, it has been sending back troubling signals that have left the entire space industry in shock. Are these disturbing transmissions the result of a technical malfunction, or could they be the work of extraterrestrials? Join us as we uncover the truth behind these unsettling messages. Since the dawn of history, scientists have been captivated by the mysteries that lie beyond our world. This fascination led to the launch of groundbreaking space missions, such as the Pioneer 1 and Pioneer 2 spacecraft. These missions, which had been in the planning stages for years, began with the launch of Pioneer 2 from NASA's Kennedy Space Center on August 21, 1977. Just 14 days later, on September 5, Pioneer 1 followed suit. These twin spacecraft, each weighing 720 kilograms, about the size of a small car, were launched on a trajectory that would take them through the outer planets. Throughout their incredible journey, these explorers traveled in different directions and at varying speeds, culminating in a key moment on December 15, 1977, when Pioneer 1 surpassed its twin in distance due to their different paths. Since then, Pioneer 1 has become a priceless asset, providing a wealth of data and uncovering space-related secrets. Before delving into the alarming new discoveries made by Pioneer 1, let's revisit some of its historic achievements. During its Jovian imaging mission in 1978, the spacecraft was positioned about 265 million kilometers from Earth. From this vantage point, it transmitted a stunning array of photographs. In January 1979, it embarked on an extraordinary 100-hour endeavor, capturing time-lapse footage of Jupiter, showing 10 complete rotations. This collection of 3,750 images allowed scientists to observe Jupiter's magnificent movements in unprecedented detail. In the months that followed, Voyager 1 ventured through Jupiter's moon system, making a groundbreaking discovery: a previously unknown small ring around Jupiter, along with the identification of 2 new moons. These revelations expanded our knowledge of Jupiter's fascinating space environment. In an effort to avoid a potential collision with Titan, one of Saturn's moons, NASA executed maneuvers to adjust Voyager 1's trajectory. The spacecraft continued its cosmic journey around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. With the conclusion of the Saturn mission, scientists decided to move the Pioneer spacecraft beyond the limits of our solar system, at an astounding speed of 325 million kilometers per year. In January 1990, a new chapter began with the Voyager 1 interstellar mission. During this phase, the spacecraft captured some of the most iconic photographs in history, including the famous family portrait of the solar system. On February 14, 1990, when Voyager 1 was 6 billion kilometers from the Sun, it took the famous pale blue dot image, showing Earth as a tiny speck in the vastness of space. This image, part of a set of 60 photos, became one of the most profound reminders of humanity's place in the universe. Voyager 2 also achieved a remarkable feat in 1986 when it became the first spacecraft to fly by Uranus. 3 years later, it flew by Neptune, remaining the only spacecraft to have taken such a path. As the Voyager missions continued their journey, NASA implemented measures to extend their operational lifespan. Non-essential parts and heaters were deactivated to conserve energy, ensuring that these daring explorers could continue their mission well into the next decade. The projected end date for their mission is set for 2030. For the scientists and engineers who have been involved in these remarkable missions from the very beginning, the culmination of the Voyager projects is both a source of immense pride and a touch of sadness. Their unwavering dedication and hard work have far exceeded initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, led to numerous scientific breakthroughs, and sparked the imaginations of countless researchers and space enthusiasts. Pioneer 1 and Pioneer 2 were not just ordinary space probes. They were meticulously designed as durable platforms capable of withstanding the harsh conditions of deep space. With a rotation rate 15 times slower than the second hand of a clock, These
The Deep
spacecraft
Space
continue
Network,
to exceed
DSN,
expectations
plays a
and
crucial
inspire
role
awe
in
supporting the Voyager 1
community.
mission, as it allows the spacecraft to send and receive signals over vast distances. As Voyager 1 travels beyond the outer reaches of our solar system, its signal weakens by the time it reaches Earth, but the DSN's large radio antennas are capable of detecting and amplifying this faint signal. Through this communication, Voyager 1 transmits valuable data back to Earth, and the DSN also sends commands to the spacecraft, allowing scientists to adjust its trajectory, instruments, and other operations. The DSN serves as a vital link between Earth and the farthest human-made objects in space, ensuring that these missions continue their work even billions of miles away. It operates 24/7, like an unblinking eye on the universe, keeping us connected to space probes even in the farthest reaches of our exploration. The Voyager missions exemplify the power of collaboration and innovation, with the DSN enabling scientists to overcome the vast distances between Earth and distant worlds. The spacecraft have carried out their remarkable journeys with the DSN, ensuring they were never truly alone. However, as Voyager 1 nears the 45th year of its journey, some anomalies in its performance have raised concerns. Voyager 1 is currently sending puzzling messages back to Earth, which suggest it may be uncertain about its precise location in space. This is particularly surprising given that the initial data from Voyager 1 were vast and extraordinary. Upon investigation, NASA scientists discovered that the cause of the distorted data was related to the spacecraft's Attitude Control and Navigation System, AOCS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position. A malfunction occurred when the system switched to a faulty onboard computer that had been inactive for years. Engineers were able to correct the issue by instructing the spacecraft to revert to the correct computer, and now accurate data is once again being transmitted to NASA. However, the reason behind the switch to the faulty computer remains a mystery. NASA researchers speculate that a command from another malfunctioning system may have triggered the issue, but they have not yet pinpointed the exact cause. To investigate further, Susan Dodd, the project manager for the interstellar mission, announced plans to conduct a thorough memory readout of the spacecraft and examine its operations. Despite the irregular data transmission, the spacecraft itself appears to be functioning normally, with none of its protective systems being triggered. This suggests that Voyager 1 has not been forced into a safe mode, and its signal strength remains strong. One potential factor contributing to the inconsistencies is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can cause significant challenges for spacecraft. High-energy particles from distant stars and galaxies can penetrate spacecraft structures, leading to electrical disturbances, data corruption, and memory errors. Additionally, the temperatures in the vastness of space can swing from freezing cold to scorching hot, placing immense stress on the spacecraft's components. Despite extensive testing and engineering to ensure Voyager 1 could withstand these conditions, the harsh realities of space still take a toll over time. An intriguing possibility, though far from certain, is the idea of extraterrestrial interference. Could Voyager 1's strange behavior be the result of actions by intelligent beings from beyond our solar system? While this concept may seem more like science fiction than reality, the vastness of space and the multitude of exoplanets it contains leave room for speculation about civilizations far more advanced than ours. However, before jumping to conclusions about alien involvement, scientists are diligently examining every aspect of Voyager 1's behavior, considering all possible explanations, including technical errors, radiation effects, or other unknown factors. While the cause of these anomalies remains unclear, one thing is certain: the mysteries of space continue to captivate and inspire, driving our relentless pursuit of knowledge and understanding of the universe. The shuttle's limited plan choice led to visual obstructions, but it still managed to capture valuable pictures and data as it traversed the vastness of space. Even before reaching the outer planets, its incredible imaging capabilities began to astonish both scientists and the public. The spacecraft started sending images of Jupiter even before it reached the gas giant, and these early images, showcasing the swirling clouds and the iconic Great Red Spot, delighted NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The shuttle's instruments detected unusual signals from Io, which were confirmed by the stunning images they captured. The images revealed towering volcanic plumes and a surface marked by volcanic activity. One of Io's most notable volcanoes erupted with a force multiple times greater than Mount St. Helens, covering an area nearly the size of France. Although the spacecraft's cameras were eventually powered down to conserve energy and memory before heading into interstellar space, it's important to note that the photos it captured did not include Mercury or Mars for various reasons. Apart from the Voyager missions, NASA has also launched other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Pioneer 10 made history on February 17, 1998, when it became the most distant spacecraft. It continued its journey for another 14 years, eventually entering interstellar space on August 25, 2012. Despite this remarkable milestone, NASA didn't publicly announce it until 2013. The success of the Pioneer missions can be attributed to various strategies, with one standing out in particular: gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their bold mission to explore the outer reaches of our solar system. To reach these distant destinations and gather important data, the spacecraft required more than just their onboard engines. They needed an extra boost, which gravity assists provided. Imagine the two spacecraft, Voyager 1 and Voyager 2, embarking on their monumental journey through the solar system. Instead of relying solely on their engines, they performed a cosmic dance with some of our solar system's giant planets. These planets, with their immense gravitational pull, acted as slingshots, propelling the spacecraft forward. This technique saved valuable fuel and enabled the spacecraft to reach multiple destinations. Understanding gravity assists, or gravitational slingshots, reveals the genius behind this strategy. The idea is to harness a planet's momentum as the spacecraft passes by, transferring some of that energy to the spacecraft. For instance, when Voyager 1 approached Jupiter, the giant gas planet's gravity pulled on the spacecraft, accelerating it to a higher speed and giving it a significant boost. Executing a gravity assist maneuver requires extreme precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot effect could have deviated the spacecraft from its planned trajectory. The level of accuracy required was staggering, yet the brilliant minds behind these missions successfully performed gravity assists multiple times, allowing the Voyager spacecraft to embark on their extraordinary journeys. Voyager 2, for example, used gravity assists from both Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were essential in making the grand tour of the solar system possible. Both Voyager spacecraft owe much of their success to these gravity assists, which allowed them to continue their journey into interstellar space. Gravity assists are simple in concept but incredibly complex in execution. Voyager 2's grand tour required such precision that any miscalculation in these slingshots could have resulted in a failed mission. Yet, the dedicated scientists and engineers behind these missions remained focused and unwavering in their quest for knowledge. In addition to gravity assists, another vital component in ensuring the success of the Pioneer missions was the Deep Space Network, DSN, often regarded as the interstellar communication line that kept us connected with the far-reaching Pioneer spacecraft. While less glamorous than a rocket, the DSN is equally crucial. It consists of a network of large radio dishes strategically positioned around the globe, including locations in California, Spain, and Australia. These massive dishes, ranging from 26 to an impressive 70 meters in diameter, act as powerful amplifiers, enabling communication with spacecraft traveling beyond our planet. The Voyager spacecraft, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To receive the data they sent and provide them with new instructions, a robust communication system was essential. The Deep Space Network played a key role in maintaining this crucial connection.